Okay, so let's review what you should have learned about discontinuities in pre-calculus, but also through the Desmos activity you just did. So let's start with our first example here. We've got a function, and at x equals c, the function is discontinuous because, well, as you can see from the picture, there's a hole, but you cannot say that it's discontinuous because there's a hole, because if you say it's discontinuous because there's a hole, you're saying it's discontinuous because it's got a discontinuity, which is obviously redundant. So the reason it's discontinuous is because f of c doesn't exist, or the function is undefined at x equals c. So there has to be a point there. A point has to exist for a function to be continuous. In our second example, the point does exist, so f of c does exist, but we have a jump discontinuity here, right? So what we would say is that the limit as x approaches c, and don't forget to write of f of x. You cannot just write limit as x approaches c. It's limit as x approaches c of f of x doesn't exist. And don't write equals dne, that doesn't really make sense. You would just write dne, doesn't exist. Don't put an equal sign there. All right, and then lastly, we have a point, f of c exists. The limit exists because both sides of the graph are approaching a point, but those are two different places, right? So this one is discontinuous because f of c does not equal the limit as x approaches c, again, of f of x. So make sure you have that of f of x there. All right, so likewise, the definition of continuity. So let's say you have to say f of x is continuous. So you would say f of x is continuous if, and only if, that's what IFF means, if and only if, f of c exists, I should say at x equals c. f of x is continuous at x equals c if and only if f of c exists, the limit as x approaches c of f of x exists. It's basically just the opposite of what we just said for discontinuities. And f of c has to equal the limit as x approaches c of f of x. Or you would say f of x is continuous over its domain if and only if for all x equals c, these three things are true. So make sure if it says use the limit definition of continuity or formally define if a function is continuous or discontinuous, please make sure you're using your limits and your function notation properly. Don't just say it's not continuous because it's got a discontinuity. Or, yeah. Okay, anyway, infinite limits. So